welcome to EC Electronics. This is a video on nodal analysis in network theory or network analysis subject. Okay, so whenever you are studying any network analysis problem, whenever you are attempting some questions from network analysis, one of the most confusing thing which I feel is this nodal analysis. Because you have to write the equations for current for each nodes and you don't know the direction of current and how to take the direction of current and voltage. So this is actually really confusing when you are attempting this network or circuit questions. Okay, so in this video, we are going to simplify this problem. That is, we are going to study how to apply the nodal analysis for each nodes for a particular network or a circuit. Okay, so how to take the direction of currents, how the current flow actually is happening, how the voltages are being taken. So all these things we are going to do or we are going to discuss in this video. Okay, so let's see. So for the basic study of this nodal analysis, I have just drawn a very simple circuit here which consists of only 3 resistors and 2 voltage sources. And what I'm going to do is I'm going to write the nodal equation for this particular node, that is this central node. Okay. So before seeing what is actually nodal analysis, you should know what is a node. A node is, you may be familiar with this node term in graph theory also. This node means is a interlocking or the union of 2 branches or 2 or 3 branches or a number of branches is called a node. So here this is a node. Okay, so what we are going to do is we are going to write the nodal equation for this node. Okay, before writing the nodal equation, actually what is nodal equation representing? Nodal equation is actually the current equation of a particular node. So when a node is there, you know, it is a union of branches, various branches. So these branches will be having currents, right? So these currents will be either getting added or getting subtracted or will combine at this particular node. And we are going to write the equation for current in this particular node. So when you are hearing this current equation at a node, the first thing that should pop up in your mind is the Kirchhoff current law. So that is what we are applying here. That is, we are going to write the Kirchhoff current law for this particular node if you are going to write the nodal equation for this node. So we know that according to the Kirchhoff current law, what is Kirchhoff current law? It states that the algebraic sum of currents present at a particular node is equal to 0. Or simply we can say that the sum of currents coming to the node is equal to sum of currents leaving the node. Okay. So when some currents are coming to the node, it will be equal to the current flowing out of the node. So for this writing of current equations, we should know the directions of current. Okay, that is the directions of current present in each branch. Only then we should know or we could know that whether the current is flowing into the node or whether the current is flowing out of the node, right? So all these things we are going to see in this video. So let us see how the nodal equation can be written for this particular circuit. So here I am taking this node and I'm going to write the nodal equation for this node. Okay, and there are 2 other branches. No, there are 3 branches connected to this node. So let us see how the current flow is happening in these 3 branches, that is 1, 2 and 3. Okay, so there are 2 voltage sources here, which is one is 10 volt and other one is 20 volt. So let us try to figure out the current direction through this 10 ohm or through this branch. Okay, we all know that according to the convention of current flow, current always flows from the positive terminal of the battery to the negative terminal of the battery. So that is a convention we are following. Okay, so here there is a 10 volt and there is a positive and the negative terminal. So the current has to flow from which terminal? It is from the positive terminal of the battery that the current is flowing. So the current is flowing here in this direction. Okay. So the current is flowing in this direction because the current is starting from the positive terminal towards the negative terminal. So the current is in this direction. Okay. So I am marking the direction of current here. It is in this direction. Similarly, for this voltage source, there is a positive terminal, there is a negative terminal. So the current flows from positive to negative. So here also the current is flowing from positive to negative and the current direction is towards this 20 ohm like this. Okay, so we have marked the current flow in these two branches, that is this branch and for this branch. And also when the this current is flowing through this resistor, that is 10 ohm and also 20 ohm. So what is the direction of voltage in this 10 ohm and this 20 ohm? Here again, there is some voltage developed in this 10 ohm resistor when the current is flowing, right? According to the Ohm's law, we know that V is equal to I into R. So what will be the sign of the voltage? It is from positive to negative. Okay, and also here the current is flowing in this direction. So this is positive and this is negative. I hope this is clear. That is, we follow the convention of current flow from positive to negative. So whenever a current is flowing from one direction to other direction, means that this direction, if the current is flowing, this is taken as positive, this is taken as negative. So we have obtained the directions of current for this branch and this branch. Okay. And we need one more current, that is, we have one more branch, this branch, right? So before that, I'm going to take the voltage present at this node as VB and the voltage in this particular point as VA and this point as VB. Okay, we know that this VA will be equal to 10 volt. So VA is equal to 10 volt because this voltage is equal to this voltage, right? Also, VB is equal to 20 volt. So, VB is equal to 20 volt. Okay. So, we have obtained three voltages here. VA, VB, sorry, it is VC. I've already taken VB. So, this is VC. Okay. Now, everything is clear. VA, VB and VC. And also, we have obtained the directions of current in this direction for this branch and this direction for this branch. And now we are not understood with this particular vertical branch. So here if you see, this is a reference node or a ground node. So the voltage present at this node, since it is grounded, will be equal to VF is equal to 0. 0 volt is a voltage present at this node. And we have taken this voltage as VB, right? So when there is a current in this branch, from where to where the current has to flow, we know that the current always flows from high potential to the low potential. Because that is why we are taking the convention as positive to negative. The current flow is taking as positive to negative because from the higher potential, the current is flowing to the lower potential. So, from where to where the current should flow for this branch? From VB to the ground, because we know that this is 0, this is some potential VB. So, current flows from the VB to the ground. Okay, and here the voltage signs will be from this positive to negative. Now we have obtained the direction of currents for all the branches connected to this node. Let this node be node 1. Okay, so this node be node 1 and we have obtained the directions of current of all branches connected to that particular node. So if we have obtained till this, we can write the nodal equation. Okay, I hope this much is clear to everyone, because if you are going for any exam, this is important. So if you are preparing for any exams, please do watch this video till the end. Okay, so this much is clear for everyone. Now, I'm going to write the nodal equation for this node 1. So as I said earlier, this nodal equation is equal to Kirchhoff current law. So I'm going to call this current, there is some current here, right? So this current I'm going to call as IA, and this current I'm going to call as IB, and this current I'm going to call as, sorry, I'll call this as IC, and this current I'm going to call as IB. So according to the Kirchhoff current law, what will be the current equation for this particular node 1? Here, the current IA is coming to the node, IC is coming to the node, and the current IB is leaving the node. So, the equation will be IA plus IC is equal to IB. Okay, so this is the current equation. Now we don't know the values of IA, IC and IB, but we can write these current terms in terms of voltage by resistance value according to the Ohm's law. And also I have done a detailed video on Kirchhoff current law. If you want to see the video, I'll share the link in the description box. Okay, so I'm going to expand the IA, IC and IB in terms of voltages. Okay, so first I'm going to write the equation for IA. Okay, so the current flows from this direction to this direction for this branch. So what is the equation for IA? Current equal to voltage by resistance. Right? So this is a simple explanation of Ohm's law. So current is equal to voltage by resistance. Now we need to know the value of voltage because we know that the resistance value is 10 ohm. What is the voltage value? Voltage is from this to this the current is flowing. So it is VA minus VB, that is positive voltage minus negative voltage, because the total voltage for this branch is the difference of these two voltages, right? That is these two voltages difference is present in this particular branch. Okay, so the voltage difference is taken as V plus minus V minus. I'll write the general equation, that is V plus minus V minus by resistance. So here V plus means the positive voltage. So here the positive sign is here. So the plus or V plus is VA and the negative voltage V minus is VB. Or if you find this difficult to understand, just keep this thing in mind that from positive to negative voltage, that is this is the positive voltage and this is the negative voltage. Since the current is flowing from positive to negative or the higher potential to lower potential, this is the higher potential or higher voltage and this is the lower voltage. So VA minus VB. Okay, so VA minus VB by how much? 10. Okay, now I'm going to write the equation for IC. I'll write it here. IC is equal to, IC is the current present in this branch. So IC, what is a higher potential? Which is VC, that is current is flowing in this direction, right? So V plus is VC and V minus is VB, or higher potential is VC and lower potential is VB. So the equation is VC minus VB by the resistance value is 20. Okay. Now we have to write the equation for the last current, which is IB, the current through this branch. So the current equation is from V plus minus V minus or VB minus V minus. Here the V minus or the lower potential is 0 because the current is going to the ground. So the V minus is taken as 0. So VB minus 0 by 40. I'll write the equation here. That is the current IB is equal to VB minus 0 by 40. Or you can write it as VB by 40. So now we have obtained the value of IA, IC and IB. Now I am going to write my nodal equation by substituting the current values in the KCL. So the equation will be, I'll rub it and write it once again. Okay, so the equation is, or your nodal equation is VA minus VB by 10 plus, because current IC is coming, right? So plus VC minus VB by 20 is equal to, or minus is equal to VB by 40. So this is your nodal equation for the node 1 or this node. Okay, so this is how you have to write the nodal equation. First you have to find the directions of current and then you have to apply the Kirchhoff current law for the particular node where you want to write the voltage or the nodal equation. Okay, so we are writing the current equation, that is sum of currents we are writing in terms of voltage by resistance. Okay, so I hope this is clear. We will do one more example which is little more bigger circuit than this. Okay, we are going to perform the nodal analysis of this particular circuit. For the earlier question or the circuit also, we have not simplified, I've just written the nodal equation. So the simplification part is mathematics, so you can do it. So I'll help you to write the nodal equation. Okay, so here also I have taken two nodes, that is this is V1, this is V2. Okay, so this is a circuit which consists of a voltage source and a current source, and there are two nodes for which I am going to write my nodal equation. Okay, so in the earlier circuit also, first we have drawn the directions of current. Okay, here also we are going to mark the current direction to make our job easier to write the nodal equation. So first there is a voltage source here, so I'm going to start from this branch. Okay, so there is a voltage source here and the current flows from positive terminal to the negative terminal. Okay, so the direction of current here is from here, the current will start flowing, and the direction of current is like this. Okay, so this is the direction of current for this particular branch. And for this particular branch, we know that this is a ground. So the voltage is Vf is equal to 0. So the current flows from this V1. I've taken the voltage in this node as V1, and this node I have taken the voltage as V2. So these are my two nodes for which I am going to write my nodal equation. So this is the voltage is V1, this is ground. So the current always flows to ground. So the direction of current is from V1 to ground, or in this direction. Here also this is ground, this is V2. So the current flows in this direction. Okay. Now there is a current source of 2 ampere and the arrow of the current source is towards up. That is indicating the direction of current, right? So the current is flowing from this direction to this. So this is the current flow in this particular branch. Again, we have obtained the current of this branch, this branch, this branch, and this branch. So the left out is this 2 ohm resistor. So if you take the case of a 2 ohm resistor, actually you can mark the direction of current towards this or this, because we are not really familiar in which direction the current may flow. So we can mark the direction in towards the V2, or if you want to mark it towards the V1, you can mark, but your equations will change likewise. Okay, so if some branch is unknown, just mark an arbitrary direction towards whichever node you want and then solve the equations. So the equations will change likewise for V1 and V2. Okay, so I have marked the direction towards the V2 and I'm going to solve my Kirchhoff current law, or I'm going to write the nodal equation. Okay, so the voltages are 10 volt and there is a current source here, right? So the direction of the voltages of the resistors I'm going to mark. That is, this is positive, this is negative. Here again, this is positive, this is negative. Here this is positive, this is negative. Here this is positive and this is negative. Now I'm going to first write the nodal equation for my V1 or my node 1. This is my node 1. This is my node 2. First I'm going to write the nodal equation for my node 1. Okay, so let us see what are the currents coming to the node. Only this current is coming to the node. I have not given any names for the current. If you want to give the names for various current, if you are a beginner, then start naming the currents. But if you go on practicing, there is no need for writing current names. You can simply write the current in terms of voltage by resistance. Okay. So the current is flowing from this direction to this direction. So the higher voltage is 10 volt and the lower voltage is V1. So 10 minus V1 by the resistance value is 1 ohm. So 1. So the current is coming. So it is a positive current. Then here the current is flowing out of V1. So it is negative minus from this, that is from V1 the current is flowing to V2. So V1 minus V2 by 2. Because here the positive voltage is V1 and negative voltage is V2, or higher voltage is V1, lower voltage is taken as V2 by 2. Now this is the equation for this particular current. And for this branch, again the current is moving out of this node 1. So minus V1 minus 0, right? This is a ground. So V1 by 5 equal to 0. Okay, so if you see, I have taken the currents flowing out of the node as negative and the current flowing to the node as positive. So this is actually Kirchhoff current law. So this is your nodal equation for your node 1. Okay, now I'm going to write the equation for node 2. So for node 2, there are two currents coming towards the node and one current through one branch is flowing out of the node. So let us write the equation here. So this is the positive voltage, this is negative voltage. So V1 minus V2 by 2. V1 minus V2 by 2. Then plus, this is a 2 ohm directly coming. So plus 2, we are writing the current equation, right? So there is a current coming from a current source directly to the node, means just add that current, that is 2. Then here there is a current flowing out of the node, so minus, then the voltage is V2 minus 0. So V2 by, that is there is a minus 0, I am just neglecting it. So V2 minus 0 by 10, that is V2 by 10 is equal to 0. So this is the nodal equations for node 1 and node 2. Now if you solve this two equations, you can obtain the values of V1 and V2. And also by using V1 and V2, you can find the current values also. Okay, so this is how you have to write the nodal equation. I hope this video was useful, because in all the exams connecting to electronics, if you are attempting any network theory questions, then surely you have to face such a question. I hope this video was useful for such preparations. If yes, please do give this a thumbs up and also share this video with your friends. Okay, so I am trying to make the subjects, the hard topics, simpler in each of my videos. That is my humble attempt. If you like this video, please do subscribe to the channel and also keep on watching for more such videos. Thank you.